Well, good morning again. Today we're going to start working with something called MicroObservatory.
Samantha Parker's students have recently learned about the solar system and are now beginning to explore the larger universe of stars, nebulae, and galaxies by taking and analyzing their own images using the MicroObservatory online telescope network.
I'm going to assign each one of you a category. Some of you will be taking pictures of galaxies. Some will be taking pictures of star clusters. Some will be taking pictures of nebula. Doesn't matter if you don't really know what a galaxy is, what a star cluster is, or what a nebula is. The objects are labeled as such, so you'll know what to do. Oh, just to let you know, what's going to happen, you request an image, you've given them your email address. Tomorrow, you'll get an email message saying your photo was taken, go to this link to pick up your image.
Today, students are taking their own images with the telescopes and also going to the image archive to download images taken by other student observers.
Now, stars is what you're doing. So you decide whether you want a shorter exposure or a longer exposure and type in how many seconds you think would make a good length for your picture.
Whoa.
Any of those. We'll try one from Massachusetts instead of Arizona, maybe.
Yeah.
You know.
Yeah, there we go. Okay.
The next day, Sam has her students download and print the images they took and provides them with a set of reflection questions for analyzing the images.
I don't know. There was another one, so let's check that out.
Does it look nebulous?
Sure.
Do you know what nebulous means? Cloudy, fuzzy. That's Jupiter. We have, you guys tell me what that is?
That's Saturn.
Okay.
That's a cluster or something now.
Okay, what do you think that is?
A nebula?
Nebula? Nebula or a cluster? Something?
Yeah, something.
We'll see.
It's definitely a galaxy.
Yeah.
Definitely a galaxy. Okay, so you guys have a strong sense.
Cool.
Moon.
That would be the moon. So you have a strong sense of what you're looking for. Yes, you are taking all of these.
I like to take a picture like that.
Same way you did. Same camera.
But it's
You
like a whole entire,
can take a picture that looks just like that.
It's like a galaxy though.
Yeah?
That's weird.
Yeah.
That's kind of cool.
Does it have something to do with the
So can we just take any one of these?
Wait. Yes? What was your question?
with the zoom or whatever on the lens?
These are all taken at the same, they're not zoomed in at all.
How does that work though? There's no way that you can see something like that with your naked eye, or like a zoom that gets the moon like that.
Well, hold on. We're using a telescope.
Yeah.
So it's a camera taking an image through the telescope. So the telescope is magnifying
Oh.
anyway.
Oh, okay.
And what can a camera do that our eye can't do? Longer exposure.
All right.
So you're right that your eye, if I looked at that through that same telescope with my eye, I may not see that. But if you could stare at it and you could collect photons, the same way that a camera could
Yeah.
collect
Oh, right,
photons,
yeah.
then you might get that.
Green and blue.
Physics teacher Jim Kernahan has chosen to have his students present their images to the class for discussion.
You guys are a pair, right? Choose out of all your images so far 4 images that you are proud of that show something interesting that you want to share with everybody. These are your holiday pictures. And then 1 image that confuses you, doesn't make any sense, wasn't what you expected, looks odd. That you want the help for the rest of the class figuring out what it looks like, what it means.
This is our Crab Nebula.
Ooh. Ah.
I think this is a 60-second exposure.
60 second?
Yep.
No filter?
No filter.
Sometimes clear filter's just the way to go.
So what is that?
Well, it's the nebula. It's the cloud of gas and dust.
Yeah.
And you can see that bright center,
Yeah.
which must be a star in there.
Must be a star in there.
This most massive.
Or maybe the core of the nebula. And you can see... Oh, no, you can't. Never mind.
You can see stars.
Are the stars nearer or farther?
Closer.
These?
Yeah.
Actually, you can't tell, can you?
I have no idea.
They're all in our galaxy.
Right.
So you really have no concept.
Okay, I got a really good picture of the moon. This is inverted, of course, because otherwise I'd use way too much black ink. And surprisingly, I used a 0.05 second exposure time, and I didn't have any problems with underexposure or anything. Well, I guess no problems, meaning that the area right before the night side of the moon starts was still pretty clear.
Show us the globular again.
This is the globular. Do you have it? No, I didn't print that. Oh, that one's on the web. But this is the globular cluster.
Okay.
It's up in the corner if you can see it. So, I mean, we didn't have a problem with this image. You can see that, like, some of it's overexposed on the other stars. Like, there are a few, like, streaks right here, but generally speaking for this, like, it looks pretty good.
Could you count how many stars are in that globular cluster?
By posing questions that students can answer from their images, Jim models an important skill that they can continue to use as they investigate their universe.
They're all bled together.
Okay. How would you estimate?
Maybe if you looked at the pixel count. I mean, like, the problem is that, I mean, just saying that, like, they blend in together, like, in the middle. On the outside, it's, like, a little easier to figure out how many there are on, say, this, like, little circle right here on the outside. So, like, if you exposed it enough you overexposed it enough to get the outer ones like this, and then you underexposed it enough to get the inner ones.
Okay.
And then you sort of could estimate. I mean, you wouldn't get, like, an exact count, but
Right.
yeah, so.
Well, when we say this galaxy has 100 million stars, 10 billion stars, do you think someone counts?
No.
This galaxy has a 1,273,000,000. This galaxy has... No, they're all estimates.
NGC 2244.
NGC 2244, it's an open cluster.
Right.
Wow. Could you count those stars?
You could get a very educated guess.
Could you
as
count
to
those
how-
stars?
Like right now, yeah.
If I really wanted you to count each and every one of those stars, you could count it?
Some of them are blended in, but for the most part, yes. And it's not processed anything.
Could you tell which stars are in the open cluster and which stars are just happen to be in the same field of view?
Yeah, you can't tell distance. Intensity, right?
Well, how do you know that just by looking at that? Does it look like there's a cluster of stars there?
Yeah.
What makes you say that there's a cluster of stars there?
Because there's a lot of stars in one area.
So in one space, there's more stars than some other space. Is there an average number of stars per square inch?
Oh, maybe you can figure it out with pixel.
What, like star density? There's an infinite number of stars per
Well,
square
just from
inch.
this
It's
picture.
not visible to the
Yeah.
naked eye. You can find the star
here's a
density
square
on
inch.
there.
Is there a certain number of stars there?
Probably like 20,
How about down here?
30, 20.
How about over here? Just look at every square inch. On average, they're going to be about the same until you come here.
50.
Then you're going to get a lot more.